Now it is my pleasure to introduce our keynote speaker, Dr. Tom Wagner, who is Associate Director for Earth Action in the Earth Science Division at NASA headquarters. Hi, Tom. I'm glad we got the camera working. And really, Dr. Wagner is a dear friend. It's really my pleasure to introduce him to you, the community. He manages programs now in this role as Associate Director for Earth Action. He manages programs that apply NASA science and Earth observations to address societal challenges. And in the Space Apps program, we know Tom as one of our longest standing and most devoted subject matter experts. Tom's written numerous challenges throughout the years. And Tom, correct me if I'm wrong, but I think you probably judged more than anyone else more Space Apps throughout
It's
the
always
years.
been a pleasure, so it doesn't matter how many.
Yeah, really appreciate Tom's support. His extensive tenure at NASA since 2009 has spanned research and space missions in both Earth and planetary sciences. I had the privilege of meeting him about 15 years ago when he was project scientist for Cryosphere, charged with managing NASA's Earth science in climate change, polar science, and sea level rise. In that role, Dr. Wagner served as project scientist for missions such as ICESat-2 and IceBridge, mapping global topography and polar ice. More recently, Tom also oversaw selections for spaceflight missions like TROPICS and EMIT, studying hurricane formation and global geology, as well as Da Vinci and Veritas missions to Venus, which he oversaw as senior program scientist at NASA's Planetary Science Division. And in that role, Dr. Wagner also served as program scientist for the Dragonfly mission to Saturn's moon Titan. And you may remember one of his challenges about traveling to Titan. With a PhD from MIT in earth sciences, Tom's expertise extends from volcanoes to marine sediment cores. He has also collaborated on various interdisciplinary projects, and I know he enjoys consulting on science entertainment projects. So I do believe there's a chance you've seen a movie that Dr. Wagner has consulted on as an expert over the years. So without further ado, Tom, thank you so much for coming to talk with the Space Apps Collective Genius Summit. Without further ado, over to you, Tom Wagner.
Hey, thank you very much, Sarah. That made me feel old, that intro.
It made me
And
feel old too, actually. I'm sorry. We should have talked
like
about it
15
beforehand.
years we've known each other, right? So thank you very much for having me. Couldn't be more excited to be here. Can we go to the next slide? I just want to just start out for all of you that joined us tonight. I just want to let you know how much we literally love Space Apps at NASA headquarters, right? It goes from everything from writing the challenges, they're fun for us to do. They are kind of a reminder for us to think about what the big questions are in our field. We enjoy seeing your responses, everything from kids who made a video through to people who actually coded a new tool, even using some of those solutions. It really helps keep us motivated. It reminds us about why we got into the field in the first place. And it gives me hope for the future. That's something I'm going to talk about at the end. Go to the next slide. So what do I hope that you're going to get out of Space Apps? I'm going to take you on a little bit of a journey. Let's go to the next slide. Kind of a touch going through my career through to what kind of skills have played a role in that, what kind of skills I think that you're going to get out of Space Apps. But, again, being a little bit older, I grew up in the 70s, right? And I want you to think back. This is the time before we even really had satellites. Nobody had a personal computer. We had to do things like read books, I read a lot of science fiction, adventure stories, and things like that. At least BMX bikes we still have around, but we didn't have very good cameras, and you can see the focus on that one. Let's go to the next slide. But in terms of things like Space Apps, like stuff like where you could get your hands on a technical project, there wasn't a lot around when I was a kid. My favorite toy, though, of all time had to be this Radio Shack kit, right? Which was literally springs where you could connect wires together and make circuits. And this is literally the picture of one that I had, right? And I want you to see the one that says featured space age integrated circuit, right? Because we were entering the space age, right? There's only a few years before people had gone to the moon, just a few orbiting satellites. Back then, an integrated circuit was lucky if it had like 10 transistors or 80 or something. Now we're up to billions. But the point is this, and again, I'm going to go through the lessons that I kind of hope you learn. for people like me, we learned a lot of skills with this hand-on stuff that played itself out later. Let's go to the next slide. So eventually, after a convoluted route, I majored in geology at Binghamton University in upstate New York, and then I went to MIT to go to graduate school. And I decided to study volcanoes because I thought they were really an interesting part of Earth science, very dynamic. Thought I'd get to visit all over the place. Well, turned out I did get to visit a few places, but mostly I was in a basement lab. But I got to build a lot of stuff, right? And you see that big wrench with the big nuts up on top of that press. What we were doing was squeezing rocks and melting them to recreate the conditions in the deep earth to figure out how magmas form. Let's go to the next slide. But all that hands-on stuff that I did as a kid, from working on my bike to working on things like those little circuits helped later on. Okay, but after all that time in the horrible weather of Boston in a basement lab, I really had to go someplace else. So I moved to the tropics. But I had also always wanted to do something like help people, join the Peace Corps. So I took a job teaching at the University of Papua New Guinea, worked on a few international development projects and things. The Holy Wigmen right there were actually my students at the university. By this point, these same guys are using computers by day, but in some of the villages in Papua New Guinea, you can still see people dressed that way. And it's kind of amazing how they just go back and forth. If I do look a little scared in the bottom picture, it's because, wow, that volcano was really going off. And not long before that was taken, a thing about the size of a school bus got thrown out, and I was pretty nervous. It didn't even get past the base of the volcano, but we were only a couple of miles away there. That's Rabaul Harbor volcano. But a big thing is this, right? When I finished my PhD, everybody was like, oh, you have to get into the postdoc track and kind of go on. And I just wanted to go try something new, and I think that's another wonderful thing. And that played out well for me in my later career. It was a little bit risky though, right? And as you're picking your space apps challenges and worried about biting off more than you can chew, don't be afraid to just try it, right? You know what I mean? What's the worst thing that happens? Project doesn't work out? That's fine, but I guarantee you'll learn something and do something interesting along the way. Let's go to the next slide. Okay, so then after almost 7 years in New Guinea, I came back to the US and I moved to the National Science Foundation, which is an organization that gives out grants to US researchers. And I wound up after a couple of years in the Antarctic Earth Sciences program. Let's go to the next slide. Now, I know a lot of you people that are on the call, you're into exploring, no doubt, and science and things, and you probably feel like everything to be discovered has been discovered, and what's exciting to do. Look, and nothing could be further from the truth, right? Places like Antarctica, places like the ocean, very, very little of it's been explored. There are parts of Antarctica where there's dinosaur bones literally sitting out of the ground that people have seen by helicopter. Nobody's had time to even go study them, right? I mean, some of the oldest dinosaurs on Earth, like basically the great-great-great-grandparents of T-Rex and things like that, Cryolophosaurus. But also, too, there are amazing new tools today to do science, DNA, all of the laboratory equipment that you can just get to. There couldn't be a more exciting time to be involved in science and engineering than today. Let's go to the next slide. Okay, another big lesson though, right? And this is a really important one. When you go to Antarctica, you got to chip in. If you go to South Pole Station, they have a thing called House Mouse. You got to help clean. You got to help cook, right? And I like this one because I'm the one with the shovel helping us dig our survival house for the night, right? You always want to be that person that grabs a shovel. When you're starting to work in your group, right, and you're giving out assignments, you want to be the person that says, yep, I'll take that hard thing on and I'm going to deliver and I'm going to get it done and you can all rely on it. I throw the penguin one in because those are emperor penguins. They are even more amazing in real life than in the pictures. And what happened was we landed in a helicopter and the penguins came from like a mile away, some of them walking, some of them sliding on their bellies, and they came and surrounded our helicopter. We couldn't even leave for a while. Amazing animals. And that's actually Scott's Hut in Antarctica, which you can still go to, where they took off to go on their ill-fated expedition to the South Pole. Let's go to the next one. Okay, so by about 2009, I was really getting worried about climate change. I was working in Antarctica, and we were especially looking at things like sea level rise, how we were losing ice, what the stability of the ice sheet was. And satellites were playing an ever more important role. And this is one thing just to understand too, right? some satellite data traces, like Landsat, goes all the way back to the 70s, right? And there's some early satellites up from the 60s and even the 50s. But what happened was when I started graduate school and college, 80s and 90s, we knew the satellite data was out there, but you couldn't really use it a lot, right? By the time you get to 2009, holy cow, the satellite data is amazing because we've got records now for like 10 years. And people have figured out how to pull all the errors and stuff out of it. Plus, all of our other IT, like the computers to do modeling and the techniques, that's all been developed. And all of a sudden, and you get to 2024 where we are today, satellite remote sensing is amazing, right? And there are literally hundreds of satellites in orbit above the Earth doing everything from taking pictures to bouncing radars off the ground that tell us how much moisture is in the soil. It's an incredible time to be working in this field. Let's go to the next slide. So, as Sarah mentioned, one of my first big projects was called ICESat-2. And believe it or not, right now above the Earth is the ICESat-2 satellite orbiting over the poles and covering most of the planet 16 times a day. It's got 6 laser beams very precisely measuring the height of the Earth's surface. It's very important for the ice because as the ice flows and moves out to the ocean, it goes down. We also do things like measure sea ice thickness, but we also measure forest height. Like if you want to understand how carbon is stored in the world's ecosphere, you use things like ICESat to try to understand how much forest is there and map it. Turns out you can also even see below the ocean surface and coastal areas. You can map the bathymetry really well with ICESat-2. Go to the next slide. Robotics is also a big part of what we do at NASA. The late Alberto Bahar is pictured here in the upper right. Alberto was an amazing builder. He built spider kinds of robots to go on the space station. In this case, he made a boat that we put on the Greenland ice sheet in one of the rivers, the fastest flowing rivers on Earth, to try to understand how much water was being lost and contributing to sea level rise by surface melting. But yeah, and robots also at all scales, people making miniature robots, people making giant robots. Grover in the lower right was designed to go like 500 kilometers without any servicing. Let's go to the next slide. Now, the penultimate example of this is the Dragonfly mission, which you may have heard of. It's probably going to launch in about 2028 or so. It's going to go to Saturn's moon Titan. And this is literally a flying geologist, right? It's a quadcopter, but inside it's got a mass spectrometer, it's got cameras, it's got seismometers, it's going to measure the atmosphere. And the big deal is that it's relocatable. So it's not like we're just going to land in one spot. We're going to fly around and look at different parts of Titan. Now, you probably go, well, why would we care about Titan, right? Unless you've seen the movie, which is pretty good. Titan is a fascinating planet. It's got liquid on the surface, probably methane, but we think the surface, like the bedrock on Titan, is made of water ice. And it looks like there's places where that water ice may have been melted by impact. But the other crazy thing about Titan is that there's a methane source. And as that methane goes up in the atmosphere, it gets dissociated by radiation, and it falls down as this black snow. So it's this highly reactive carbon. You've probably got liquid water from impacts. We think this might be one of the most exciting places to look for the precursors to life to get an idea of how life got its start. And for all the young people that are here on the line today, in about 10 years, you're going to see some really exciting images from the surface of Titan. Let's go to the next slide. Okay, which brings me to another point, right? One of the great things about space apps is the team element. Learning to work as a team member is one of the most important skills you can get, right? It's not easy to acquire. It can be frustrating. Other people don't work the way you do, right? All those kinds of conflicts and everything else comes up. But if you want to work, you want to solve a big problem, you are working in a team. This is just the Dragonfly science team. If you added all the people actually building it, it's like another 500. Okay. And so everything we do at NASA is about teams, right? And I would encourage you, if you find yourself getting frustrated, take a deep breath. That's normal for all of us. And that's part of the learning process for you with space apps. Everyone's laughing because everyone's like, yep, I'm on a team. I understand. Let's go to the next one. Okay. I talk to a lot of young people, and one thing that always strikes me, and it's pretty well covered in this book, is like people seem to think especially for young people, they think the only way to be a success is to be a media influencer on, whatever social media site of your choice is, or to become some kind of dot-com billionaire or something, right? There's a million other careers out there. This is a really interesting book about college students in America that are, think big money on Wall Street is the only way to succeed, right? Um, but if you want to have a great career, whatever it is, you've got to cultivate your interests, right? And let's just go to the next slide. If you all careers are kind of tough. They have their hard moments, right? And figuring out what it is that you really like to do is what gets you through the hard times, but it also gets you motivated to really, really do great work. Now, the problem, and again, when I talk to young people, a lot of times they're like, well, Tom, I'm interested in everything, right? And I'm like, okay, that's a fine starting point, right? But some things you probably like more than others. Maybe some articles in the news you read more than others, right? But the other thing to do is to just go try these different things, right? And the amazing thing about today, especially with the internet and everything else, is you've got access to resources. You can try out being a scientist, engineer, musician, historian, whatever it is you want to do. Let's go to the next slide. And so, in addition to space apps, which I couldn't be happier that you're involved with, you can go and check out doing science yourself on Zooniverse. Let's go to the next one where you can get some real data and work on things. You can also contribute to some citizen science projects. There's ones at NASA and there's other places too, right? But try out as many of these as you can just to get a feel for it. And I don't mean to limit you just to science, right? It could be music, it could be something else. Go and give it a try. And if you're college is a really tough time. I know a lot of people are trying to pick the right place with the right program. Pick a place that has a range of things so that you can try them and get involved with them when you're an undergrad. Do a project in a lab, take a variety of courses. Let's go to the next one. Okay, I bring this up also because I think young people at all levels, right, from, I don't know if we have on the call, I'm assuming it's sort of high school to grad school, right? I know you're under pressure to specialize, right? It's a really interesting thing today. It's like, well, if you don't get good at this now, you're going to be behind everybody else. There is a role for that. Specialized skills are needed to advance any field. No argument there. But it's okay to want to change directions and to want to learn about different fields. This is a really great book called Range, written by David Epstein, who incidentally was an earth scientist who quit being an earth scientist because he realized he really wanted to be a journalist. But he went and he went and looked at what made people really great at their field. And one of the things he found was that by picking up experience in a variety of fields, it made people even better at the field that they ultimately chose. But one of the other points he makes, right, is that science nowadays is interdisciplinary, right? And a lot of the questions that we need to answer are really challenging, and you have to have expertise in different fields. Let's take medicine, right? A lot of the vaccines, a lot of the basic medicines we have, they were all developed 50 years ago. All the simple stuff's done. The next generation stuff's going to be hard. In our own field of earth sciences, right? Used to be good enough to just become an expert at like, hey, I'm a sedimentologist or I'm a volcanologist. Now you got to understand the implications of that work for climate change. You may have to understand numerical modeling because that's the edge of your field is how do you simulate these things, right? So learning a bunch of different things is great. And that's why, again, I think space apps is awesome because you get to try some things, right? Let's go to the next slide. Okay, the other great thing about space apps is you actually build something, right? And you know what? If it doesn't work, that's okay. I build things all the time that don't work, especially this Google Voice kit that I tried. I went going through 2 different kits, could never make it work. But I learned a lot about Raspberry Pi, coding, and other things in the process, right? And that's kind of what I hope for you too, is like, that you can just try something, try coding in a different language, try learning about a data set. It's okay to get frustrated. I know you have limited amounts of time. You're all busy with other things, but at least go for it, right? Let's go to the next one. I'll also say this, the important thing about building things is that if you want to go on in science or engineering, there is a really good chance that you've got to build something. It could be a computer model, but believe it or not, we still use hardware all the time. You got to make those measurements that are going to go into the computer model. These are students from, I believe, UC Boulder, and they're on the famous NASA airplane called the Vomit Comet that goes up and comes down and makes you feel like you're floating in 0G for a while. And they're trying to look at how the solar panels are going to unfold on this CubeSat. Let's go to the next slide. This is also another really exciting thing for you to think about, right? The advent of CubeSats has changed education and changed space science. It's essentially free to launch CubeSats. Like when I first started working even in satellite stuff, the pre-CubeSat era, it was $200 million literally to launch something. We would take a rocket, which a lot of times was an um, nuclear ICBM from the Cold War, converted into civilian use to launch a satellite into space, and it was $200 million. And we had to build big satellites because things hadn't been miniaturized yet. Now, you can make a sensor and put it on something that's the size of a third of a loaf of bread and have it go up in space, communicate, make measurements, send stuff down, self-assemble. This is a really exciting time. The one that I'm showing here is actually a set of CubeSats called Tropics that's on orbit right now that's mapping how hurricanes form, trying to do a better job with forecasting what direction that hurricanes will go in and how they strengthen. Let's go to the next slide. Okay, as I close out, I just wanted to talk about like the elephant in the room, which is climate change. And no doubt there's going to be a lot of challenges on climate change. It's perfectly normal to despair about climate change, right? It seems like this big horrible thing that's coming, right? I know you get bombarded with these images in the media and things. Let's go to the next slide. And, you know, in a lot of ways, the future does look dire. When I left Earth Sciences for about 3 years and went off to do planetary science, I kind of took a break from climate change, and then I started reading again. And what's amazing to me is there are a lot of people that have tried to really dive in and figure out, okay, what does a warmer world look like? It's even spawned its own genre of fiction called solar punk, right? But I think one of the things that we have to do, and especially, you know, your generations, Generation X, Gen Z, Gen Alpha, who's here today with us, right? We got to get away from the hopelessness and we got to start thinking about what we're really going to do. Let's go to the next slide. So super quick, what's NASA doing about it, right? Well, we have completely shifted gears. You're going to start hearing about this new strategy that we've got called Earth Science to Action, where the basic idea is we've realized it's not enough to just, you know, tell people how bad it's going to get. We've got to start giving people tools to adapt, right? And help people mitigate what's going to happen with climate change. And the basic idea, sorry, this one got a little garbled when it went through. We have a pyramid where we look at our foundational knowledge, the satellites, the basic research. Then as you move up, we start to try to understand the Earth system and ask applications like how much is sea level rise kind of thing, right? Then what do you do with it? You know, if we give society data on how much sea level is going to rise, maybe people can plan cities better. And then ultimately, we need to play a role in helping the public understand it. But if you look at that big arrow, what we're also recognizing under this strategy is we have a lot to learn. We know that different countries, different parts of the world need different kinds of information, and it's our goal to learn that and to put it into the bottom of the period and plan things from the ground up. You're going to see more about this in coming months. Go to the next slide. Okay, rubber meets the road, right? Let's just talk about climate change for a minute in terms of the amount of CO2 what we're putting in the atmosphere. The vertical axis is the greenhouse gas emissions we have, including everything, right? From cars we drive to generating power to agriculture. The horizontal axis is time, right? And as you go from left to right, those lines are literally the amount of CO2 over time. The red line is generally the path that we're on, and that red is because it's a hotter world, a couple of degrees centigrade warmer, right? What we need to do is reduce emissions to get us down to one of those blue or purple worlds that are cooler. And this information is straight out of the IPCC report if you want to look at it. Let's go to the next slide. Okay, now you're probably going, oh, wow, how are we ever going to reduce those emissions? A lot of great stuff has gone on even since that IPCC report came out. The US passed two big laws or bills, the Inflation Reduction Act and the Infrastructure Act. If those things are implemented the way that they're intended, they're going to reduce US emissions by like 30% in about 10 years or something, right? But there's a whole bunch of other reasons to be hopeful. Renewable energy is now cheaper than fossil fuel. It's actually cheaper to build a new solar farm or wind than it is to operate an existing coal-fired power plant. Let me make sure you heard that correctly, right? It's cheaper to build a new one than it is even to operate the existing one for a coal-fired power plant. The only exceptions are a couple of places where you have like a coal deposit right next to it and things, but the prices have really come down and they're only coming down further, right? There's also synergies that everyone's recognized. There's multiple journals now looking at this, right? There are ways to combine, say, solar farms with farming and agriculture and livestock farming and things, right? Um, there's also emission reduction technology for all sectors. And I just want to go to the next slide quickly, right? This is straight from the IPCC report, so you can go and read about all this stuff yourself, right? There's technologies available across the board to do this. Let's go to the next slide. Okay, but here's the take-home point for you space appers, right? Every one of these solutions needs people like you that A, want to do the nitty-gritty work to really make it happen. And that means building things and then getting through all of the loopholes of all of the gates of society to actually make it happen. Let's go to the next slide. I'm hopeful though, right? And I'm hopeful because you Gen Z and Gen Alpha, right? You guys grew up with climate change. You know it's real and you know that we need to do something about it. And with all of the impressive things that I see you guys do in space apps and other things, I'm not really too worried about the future. And I'll close out on my last slide. Next. Yeah. When I was growing up in the 70s and 80s was pre us understanding climate change, right? The whales were about to go extinct. We had problems with insecticides that wiped out a lot of the big birds. This is the California condor over here. We even had ozone destroying chemicals. Now, I'm not going to say we solved all of these problems completely, but we did show that we had the social will together to do something about them. And I think that if we can do that, I think your generation and we can all work together and do a lot with climate change. And with that, I'll say thank you very much. I can't wait to see what you guys wind up doing.